Hello students, here we go with a revision video for computer aided engineering drawing, which carries 100 marks in the external exam, and it's a 3 credit subject in the VTU. And when it comes to the marks distribution, this is how exactly we have. We have a combination of projection of points and projection of lines, which carries 8 and 12 marks, totally 20 marks, and projection of planes, which carries 20 marks. And in the exam, it's a final semester exam, there will be one question either from the projection of points and lines combining both for 20 marks, or there will be a question from the projection of planes. There is no choice. One of the question may appear as a question number 1, which carries 20 marks, and the question number 2 will carry 30 marks, and there is no choice for that one, which is of projection of solids. And then isometric projection, which will be there for 25 marks, which will be having either the conversion or development of isometric projection by using given data, or maybe the conversion of isometric projection into orthographic projection. And there might be chances like orthographic projection sketch will be given, and they may ask in order to develop the isometric projection also. And the last part will be from the development of lateral surface of the solids, which again carries a 25 marks. So totally it is of 100 marks, which will be converted into 50 marks at the end of the semester. That is a semester exam result. Okay. So as we move on to the first chapter, that is our first module, which is a projection of points. Normally, if we give an introduction like we are going to take up the modules as the objects, what exactly we are going to view in a dimensionality, that is a 0 to the 1 to the 2 to the 3. Okay, and these points will fall under a category of a 0-dimensional object, where we are not going to do the dimension for them, but we will consider the location of them with respect to the different planes. Okay, so we'll be having a 2 planes here. One will be the horizontal plane and one will be the vertical plane, and normally we call this as a VP and this one as a HP. And the location of a point is represented with the 4 quadrants. That's number 1, 2, 3 and 4. It moves in an anti-clockwise direction, and whenever we come across for the first quadrant, we are going to specify with the above HP, that is here with respect to this line above, and with respect to this one it is in front. And one thing is common for all the 4 quadrants here, observer will be right side. Okay, so observer will be fixed here and he will be moving in this plane. And when it comes to the first quadrant, okay, so the combination of this and this, we are going to say if any point which is located in this plane or in this region will be stated as above the HP and in front of the VP. And there is a one more way by which we can say, like if any point, say for example, if I have a point, that red color dot, the front view of this one will be appearing on the VP and the top view of the same line will be appearing on the HP. So we say the front view will be above the XY line and the top view will be below the XY line. So just to give an example, we have stated here, so this is what is XY line, and a point is lying 30 mm above HP and 35 mm in front of VP. So above HP is the front view, and below, that is in front of VP, that is below XY line, is a top view. Okay, so that's how exactly. Either there are like only 2 ways by which we can state the position of a point in the first quadrant, either above in front or front view above XY line, top view below XY line. And when it comes to the second quadrant, again the observer will be here only to the right side, and the position here will be behind this black line and above this blue line, that is behind VP and above HP. So that is what we have given it here, above HP and behind VP. But when it comes to with respect to the front view and top view, the front view will be lying here itself on the black line, that is above the XY line itself. And once we rotate, okay, this HP clockwise 90 degree downward in this way, so this part will move up, so the both the views will be above the x-y line itself. So in order to state that way, we have given it here as a in the point 35 mm above and 40 mm behind. So the front and top view both will lie above the xy lines. So when it comes to the third quadrant, this region, so we'll say it is behind VP only and below HP. Okay, so as we already told it in the second quadrant, this blue color line is moved, that is HP is rotated 90-degree clockwise. So this is moved up, this is a moved up. So the top view will go above and the front view will come below the XY line. And you can see it here, okay, with respect to diagonally opposite here, the first quadrant is totally a reverse of the third quadrant. Our third quadrant is totally a reverse of the first quadrant. And when it comes to the fourth quadrant, that is here, it is again below and in front, we say. Okay, so in front of VP. So here the front view will be below only and the top view will be below only, because this whatever the HP is rotated 90-degree downward. So both the planes will be overlapping one above the other. So both views will be coming below the XY line. Okay, so these are the only two ways by which they can ask a problem with respect to the projection of a points. Okay, either they will ask you to state the quadrant in which they lie, either by giving with respect to the VP HP or by with respect to the front view and the top view. Okay. So there's one more concept with respect to the points, that is locating a side view. Okay. So to locate the side view, so we have something called a little procedure. That means if the point is given and asked you to locate the side view, either a left side view or a right side view, the first thing is to locate the point in the respective quadrant. Say for example, here it is 20 mm above and 30 mm in front of the VP. Okay, that means it lies in the first quadrant. So front view will be here and the top view will be here. That's the first thing. The second thing is there will be a 45-degree line from the intersection of XY and X1 Y1. That is, this is the XY line, this is XY Y1, and if it is asked for a RPP, sorry RSV, okay, it should be projected on the LPP, that's a left profile plane. So there should be always a 45-degree line in front of the top view, irrespective of whether the top view lies below or above. So there should be a 45-degree line in front of the top view. Then horizontal line from the front and top view, that is there will be a line from here to here, there will be a line from here to here, and the next will be there will be a vertical line from the intersection. That is, when we are going to draw a horizontal line from the top view, this line is going to intersect with this 45-degree line. From the intersection of that one, just drop one vertical line towards the front view. Okay, so once we are going to draw, so these two lines again, they are going to intersect at some point. So that intersection of will be the side view of the respective point. And here the points to be observed here is always the side view will be in line with the front view, always, irrespective of any position. Say for example, here in the first quadrant the front view is above the XY line, so the side view will be also above the XY line. Second quadrant, again same, front view will be above XY line, so the side view will also come above the XY line. But in the third quadrant, the front view is below XY line, and in the fourth quadrant also the front view is below the XY line, so side view will come below the XY line. With respect to the different quadrants, okay, you can just follow this procedure in order to get the side view, respective side view, either a left side view or a right side view. So say for example, if they ask for a left side view, okay, so then it will be appearing on the your right side, that is a RPP, right profile plane. Or if they ask for a right side view, then it will appear on the left profile plane, like that. Okay, so this will be asked for 8 marks. Okay, the question, either they may ask to state the quadrant by assuming different dimensions also, they can give the dimension and they may ask for the different combinations also. Okay, and one more important thing in the points is they will give a shortest distance. Okay, shortest distance is nothing but this diagonal. Okay, where exactly we're going to cut here, or maybe this point. Okay, so but that means they will provide this length and you need to cut an arc in order to get the length. So they will not specify this one. So at that time you can use an arc by center point method in order to get the side view of that. Okay, so that's for the 8 marks. And moving on, we have a projection of lines. Okay, so this is a one dimension where we will give a length of that one with respect to the inclination. So here there is no such a point like where we can generalize like a points are the remaining modules, but here there are 3 to 4 categories of problem where they will give a few data. From that one you need to what you call find out where the front and top view will lies. Okay, and this one is restricted only for the first quadrant. So the, again to recall, the first quadrant is above. Okay, the front view will appear above the x value and the top view will appear below the x value. So here there are two things to be remembered. One is a true length and one is a apparent length. For example, if I have a line like this, okay, this, okay, a dash b dash, if I want a top view of this one, when I am seeing from here, observing from this point, okay, so I need to have a direct straight line, okay, till the locus of one more line, and then we need to get a length of that one. So we are going to rotate. Okay, if I have a length of a front view like this, okay, so to get a true length of that one, first we need to have an arc, then straight line down the locus of B, then it is connected to the locus of A. That means things to be remembered here is we'll have a xy line, we'll have two planes VP and HP, and we'll have four locus lines. Okay, locus of B 2, then locus of A 2. Okay, first you need to find out those things. Okay, four locus lines and one xy line, and where this A and B are located, the end B and A. That means we are going to have a two lines and a four end points. So just to have a look here, you can say when we are going to read a problem, a line AB 80 mm long, that is line itself is 80 mm long, that it means like it's a true length of that one, as its end A 20 mm above HP and 30 mm in front of VP. So you can see here the A is located 20 mm, and in line with the same one the A is located below also. Okay, so it is inclined at 30° to HP and 45° to VP. That is, they have given the line itself is inclined. That means the true inclination they have given, that is theta is equal to 30° and pi is equal to pi is equal to 45°. Okay, now draw the projection and find the apparent length and apparent inclination. So very simple problem here. So once we locate any one end here, okay, the next thing will be they have given a length, give a length and take the angle. So 80 and 30, you will get this line, and 80 here minus 45, you will get this length. That means you got a true length now. So how to get an apparent length? As you said, when you see from the top, just drop a line till the locus point of a end A, then arc in order to get the apparent length, that is a top view length. Okay, so once you get this line, you can just drop one vertical line till here, and this is the front view. Okay, that's an easy way by which you can do. And this is a, you need to make this line and this line as a dark, that's a front view and a top view, and the front view inclination is called as alpha and the top view inclination we call as a beta. That's the first kind. And the second kind is they won't give the length of that one. Okay, so here we can see there is a line AB, they are not given specified any length, but they specify the location of the end point, that is end A 20 mm and 30 mm, that is the same way as the previous problem. And here they will give the other end B is 60 mm above HP. That means from here it is 60 mm, you will get a locus line very easily. Okay, that means you got a 1, 2 and 3 locus line, and you need to find out like one more locus line where exactly it falls. And there's one more data which makes a difference with respect to the previous problem is the distance between the end projector is 70 millimeter. That means the distance between end A, okay, and end B, which represent the front and top view, is a distance of 70 mm. So what we'll do here, from A we will measure 70 mm and we'll just drop one vertical line. Okay, one vertical line. Already we know the locus line of a B, and it intersects at some point. So from that intersection, if you draw, that will be the front view. Now you got one front view. So as I said in the previous problem, you just draw one vertical line from there to down. Okay, there to down. So it will intersect with the same vertical line, that is a 70 mm. Okay, so next, how to get the true length here? Okay, so now we need to have a arc. Okay, we need to draw an arc first till the B, then drop it down. Okay, so drop it down. So then we are going to get the inclination with the length with respect to the front and the top view. So you can clearly see like the alpha will be equal to 30, beta is equal to 12 degree, and the true length of that one will be equal to 82. In our computer it may be little bit difference. You can see like 82.2 and it is fine. You can just locate the things. Okay, so that's how exactly we can have it here. Okay, with respect to the second kind of a line. And the third one will be, we can see here, the third data will be the top view of a line. Okay, the top view of a line is 70 millimeter. That means they have given a length in the top view. That's not a true length. Okay, length in the top view and the length inclination in the top view, that is a beta. Okay, and the end Q is 10 millimeter in front of VP and 30 millimeter above the HP. See, always you need not think like the line will be AB only, PQ only, like always we see the alphabets and all. Now the Q is nearer and the P is away from that dot. Okay, and one end is located here. The difference between the distance of P and Q above the HP is 45 mm. So here they are not given totally above. If we take totally above, that will be 75. Instead of that one, from the locus line of A, they have given a distance, it's a 45. Okay, and determine its a true length and a true inclination. Okay, so first we will get this one, that is a top view, that is a 70 mm and a 60 length. Okay, then we have already the locus line which they have given. So you can just take an arc and a straight line, it intersects with the locus line of B, then from there you will get a true line. Okay, so like this, like we have three categories or varieties of problem. Okay, in a projection of planes. Okay, either they will give a true length and a true inclination, or they will give a location of different end points and a distance between end projector, or they will give a front view and a top view with any one of the inclination. Okay, that means like see, always you need to remember, if I want to have a true length, okay, from the front and top view, first you need to have an arc, then straight line till the end of the locus line of B. Okay, or else I have a true length, I need a top or a front view, you need to just have a straight line till the end of, that is a locus line of A, then you need to cut an arc. Okay, so if you are able to understand these three problems properly, okay, then you can solve any type of the problem with respect to the lines. Okay, so which carries a 12 marks. So next, moving on to the next one, that is a projection of planes. Okay, so there will be a question either from combination of points and lines or maybe from the planes. So this carries a 20 marks. Okay, no choice again if we get it. So whenever we look for a planes, it's a two-dimensional object, and here there are two conditions. Okay, again with respect to the first quadrant itself, either it will be resting on the VP or with respect to the HP. So in the problem, if you read the problem, so clearly they will mention whether it is resting on VP or with the HP. So if I take, okay, the first one has a it is resting on HP. Okay, so we will write this one HP, HP and a VP. So suppose like if it is resting on VP, we'll write here VP, VP and HP. Write down this first. Then when it comes to the HP, so always we will have two options here. Okay, so the two options is either it will be resting on edge. Okay, like this. You can see whenever we have any plane here, we will be having a combination of edges and corners. Okay, so first one, either it will be resting on the edge or it will be resting on the corner. Okay, that means the resting side or maybe the corner should be taken to the left side. That is for our convenience. That's it. Okay, so there is no rule like we need to take it to the left side only, just to make sure that like to proceed further further positions, it will be easy for us to locate the resting edge or corner to the left side. Okay, so that's what we say, HP first position, take it to the left side. Either there will be only two options again. Okay, there is no other what you call positions with respect to the any combination of the planes. Either it should be like this or it should be like this. There's a one more way by which you can remember this one is, whenever we say it is resting on an edge, you make sure that any one of the edge is perpendicular to the XY line. Okay, you can see this line, this line, this line, or this line, or this line. So all these lines are perpendicular to the xy line. And when it comes to the resting on a corner condition, okay, so you can remember always either a median, bisector, diagonal, diagonal, or maybe the diameter are parallel to the xy line. Okay, then it satisfy either it is resting on edge or maybe the corner condition. Okay, so resting on edge condition, one of the edge should be perpendicular. Corner condition, either of the median or a bisector or diagonal or diameter should be parallel to the xy line. And moving on, when it comes to the second position, okay, so we have said like HP, HP, VP. So first HP is done. Next HP, there will be one keyword which makes you to understand, yes, that inclination is referring to the second quadrant. That is either they will use a lamina or a plane or a surface. Okay, so they will use that one. So in this one, there will be two method, okay, by which we can understand. So most of the problem they will go give the inclination. Okay, so either they will say like lamina is inclined, plane is inclined, the surface is inclined. Okay, that's a year. Okay, so where the plane is resting on it, one of its corner, and the lamina is inclined at 45 degree to the HP. Okay, so there's one more option by which they can ask here is, it is the plane is resting on one of its corner and the opposite corner is 30 millimeter above the HP. Okay, that means, so this is the front view of that line. Okay, so in order to get this position, what we need to do here is, first you need to have one 35 mm line, that's a vertical line, then one simple just horizontal line without any dimension. Then measure the front view of this line and take arc by center point, any point on the xy line. From there you just cut arc, okay, which is equal to the front view of this one. Okay, so then it intersects at some point. You go to the trim option, trim of both the things, and move this line from the left hand and keep this left hand to the center of the arc. Okay, that you will get once you move on the arc. Then you just rotate and place this one at the dead end. So then easily you will get the inclination. So this is very important. Okay, in the VTU primer we have such a problem, maybe 3 to 4 problems where they will give an option to find out the inclination either with respect to the HP or with respect to the VP. A simple problem, but again we need to remember. So even here, if they give the inclination, we can measure the distance of this point from here to here. The same one they have asked here. Okay, they have given this one and we need to find this one. So that is with respect to the second position, with respect to the HP. The conditions will remain similar with respect to the VP also. Okay, and the last one is the third position, that is with respect to the VP. So here we are going to have the first condition, the resting edge. Okay, so now if you see the solution here, we can easily say it is resting on one of its edges and the lamina is inclined, and here the lamina, the resting edge itself is inclined to VP at some angle. That means you can see FA, FA and then FA. That means resting on one of its edge, the same lamina is inclined with respect to the same edge, and the same edge is inclined at 30 degree to the VP here. Okay, there may be, if it is resting on one of its corner. Okay, you can see here it is resting on a corner. Then we have discussed the previous this one problem, right? Like where they ask like the opposite edge is at an height of 25 mm above HP. Okay, cut an arc and I rotate, I said, right? And what they will tell here, the edge opposite to the resting corner is inclined at 45 degree to the VP. Okay, such a problems may be asked, but means like you need to find or you need to look for a word which represents the resting edge. Okay, here the edge opposite to the resting corner, even though it is resting on the corner, the opposite edge is inclined to the VP at some angle. So that is the third position. Okay, this is the first option in the third position. What is the next option? Next option is a very important one where we categorize these problems into locus line. Okay, so whenever in a problem, if they say the median with respect to the triangle, diagonal with respect to the square, diameter with respect to the circle, bisector with respect to the pentagon or a diagonal with respect to the hexagon. So all these problems we categorize under locus line. If these are inclined, you can just say, we have taken one example here. We have a square plate 30 mm side rests on HP such that one of the diagonal is inclined at 30 degree to HP and 45 degree to VP. That means diagonal is inclined with respect to the HP also, with respect to the VP also. Means if you take up all these points, all these lines will originate from a corner. So the first position, even though if they are not going to represent here or state where exactly it is resting, easily we can assume like it is resting on one of its corner. Okay, so when they say these things are inclined, we need to go for a locus line. So we have a little procedure in order to go with the locus line. That means, so here once we draw resting on a corner, so this is the diagonal AC, and the same diagonal we are going to get it in the second position. We need to measure both the lengths. So we refer this one as the first length and we refer this one as the second length. Normally they give first inclination, that is diagonal is inclined at 30 degree or 45 degree with respect to the VP. So first length and first angle, that is what is this line. Okay, so we need to first take this line, okay, the first line and first angle. Once we take up that one, from this end we are going to have a horizontal line. That is what we have specified here, horizontal line, or that line itself we are going to call it as a locus line. And the second point is arc by center point, the radius is equal to the second line, that is this one. Okay, that means from the same end of this red line you need to cut an arc on this horizontal line which is equal to the second length. Okay, next cut an arc on the locus line, that's what we did, and find the angle. That's what is nothing but a beta line which we are going to represent, and that is going to be the beta inclination. Okay, so if it is not inclined, okay, so if they say there is a word which is called as appears to be, or a top view of that whatever the median diagonal, then it's a non-locus line problem. You can just directly take that one and rotate it in order to get uh, the top view or the front view of that one. Okay, either with respect to the VP or maybe the HP. Okay, that is what is non-locus line problem. Okay, so this is again the same similar steps you can repeat with respect to the VP. Okay, so if it is resting on VP, again there will be only two options, edge or a corner, as we have showed with respect to the HP. And again second position we will be having the only three options, and again with respect to the HP we will be having same locus line, the non-locus line problem, or maybe the resting edge condition. Okay, you can just refer to that one in order to understand with respect to the plates. Okay, so then that is with respect to the 20 marks which we are going to ask it for the question number 1. Okay, and when it comes to the second question number 2, okay, that's a projection of solids. So again here we restrict only with respect to the HP. There is no option to get a VP HP here. Okay, the thing is only you need to remember only one thing, that is it is resting on HP, so it is HP and VP. So again with respect to the first condition we are going to have two options only. Okay, that is with respect to the HP, either edge or a corner. Let's see like one by one. The first position, take it to the right side, that's what's very important. Okay, in the previous that's a planes we told it to the left side, and here we are going to take it to the right side. Again just for a convenience you can take it to the left side also, but while rotating you need to make sure that like it is going to be this whatever the resting edge. Even if you are taking this as a resting edge, then you need to reverse and make sure that this point will come on a XY line here. That's very important. Okay, so we are taken to the right side, so for us it is very simple. You can just rotate in this way so that the resting edge will be here itself. Okay, so this is what is the resting edge. Okay, again the same what you call concept with respect to the resting edge. Okay, as we discussed in the planes, the edge should be perpendicular to the XY line. Okay, so if it is resting on a corner, you can see again the diagonal is parallel to the XY line that lies the right side to us. You can see here A dash, that A dash will be lying here. Thus what is very important, we take it to the right side. So that is with respect to the first position. Okay, whether it is resting on edge or maybe the corner. And when it comes to the second position, So we have two solids here. One is a prism and one is a pyramid. So we'll take up first the prism. Okay. In the second position for a prism, always it is axis inclined. Okay. How exactly? So when they gave axis is inclined, so for our convenience, when we are going to use or solve the problem using the computer, okay, we take a base inclination that will be equal to 90 minus of axis inclination. So how? You can just check it out here. So now this solid is resting on one of its edges of the base, okay, and you can see here when we are going to rotate here, so the axis is inclined at 40 degree. If you are going to use a base rotation, that is when you are going to rotate this line, you need to take 90 minus of 40. That means this base will be inclined at a 50 degree. Okay, the same way you can use it here. Okay, so resting on one of its side, and here the axis is inclined at a whatever the given angle, that means it's a 45 degree. So you can give directly 45 degree, or else you can give just 90 minus over 45 degree. This is the one important thing you need to remember when it comes to the second position of the solid. Okay, so when it comes to a pyramid, okay, so we have again the same first as the axis inclined, where we use again base inclination will be equal to 90 minus of inclination. You can see it here. That's a one option in the pyramid, and there are two very important parameters in the pyramid. Okay, so one is rests on slanted and one will be on a rest on triangular face. Here they don't give inclination with respect to the HP. Instead of that one, they will say it is resting on slant edge and a slant triangular face. In such a cases, they don't mention even the first position, okay, whether it is resting on corner or resting on the edge. But we need to know, okay, when it is resting on the slant edge, the first condition will be resting on the corner. That's very important. Okay, and when it is resting on slant triangular face, okay, like this, the first position will be resting on the edge. This is a very important thing. Most of the time students will forget in order to mention this one. Okay, so by looking at this edge, okay, they will take this one as the edge and they will follow that one. So initial position itself will go wrong and you will get a 0 marks for that one. Okay, so for that one, so you just look for the slant edge. Slant edge is a line which joins from apex to the corner. Okay, and once it is joining to the base as a corner, then the resting one will be a corner. So that's very important. That means when it comes to the second position in the prism, we have only one option where we say axis is inclined, that we need to take it as a base inclination is equal to 90 minus axis inclination. But when it comes to the pyramid, we'll be having three options here. One is the axis inclination similar to the prism, and two more is resting on slant edge and resting on a slant triangular face. Okay, so very important thing to be noted. And the last one will be again inclination to the VP, okay, where we'll be having the three options here. So as usual, like what we discussed in the planes, if you remember, the resting edge itself is inclined to the VP, and again here we'll be having a locus line and non-locus line problem. But here we don't have such an option like a planes where we said like median, diagonal, such a things and all. But here it's a very simple. If they say axis is inclined to VP, then it's a locus line problem. And if axis is appears to be inclined or the top view of the axis is inclined, then it's a non-locus line problem. Okay, so to just go with that one, the first option will be the resting edge. You can see this is the resting edge, and the same FA is inclined at 30 degree to the VP. You can see here, see this word, okay, what is that? Which is inclined, which means what? It is previous sentence, it's a resting on an edge condition. That means F and A. That is what is very important here. A simple problem, it. Okay, people will forget and they will take even though they have not specified it is axis inclined. That is what we said. Clearly make a note whenever you are reading a problem. Okay, write it down. When it is to the solids, you write HP, VP. When you are going to start reading here, they say hexagonal pyramid, side, okay, 50 axis rests on one of its edges. So first one HP, it is on edge. Okay, the base which is inclined to VP. Okay, you don't know like how to take up that one. You write VP 30 degree, that is in the third position. Draw the projection of the pyramid when the axis is inclined. to the HP at 45 degrees. So second position, axis is inclined. So now at least you need to think like, what is inclined? Did they mention axis is inclined? No. Okay, that means what is this which mean? You need to think and go for the resting edge. Okay, that is what is very important. You need to take your own time in order to just read the problem and make sure that like you are going to take up the required data. Okay, that's the first condition. And when it comes to the second condition, as I said, right, so here axis is inclined, it's a locus line problem. The procedure will remain as it is, what we have discussed in the planes. Okay, the first angle, but the length will be your axis length, not the diagonal or maybe the median length. Okay, so how to go with that one? So we'll see one by one. If they say there is a pyramid base resting on one of its slanted means resting on corner. Draw the projection of the pyramid when the axis is inclined to VP at 45 degrees. That means it's a locus line problem. Okay, axis is inclined. But if you see how exactly we're going to do, I have taken only the third position where we need to find the beta here. Okay, they have given 45 degree, we need to find beta, that's 50 degree. So same procedure again. Okay, first is the axis, that is 50, and given angle is 45, that is 50 45. We will get a line, horizontal line, then the second length arc, then move the prism or pyramid on this position. And the second condition will be, okay, so it is appears to be, you can see the changes here when the axis is inclined. Here when its axis appears to be inclined, appears to be means it's a non-locus line problem where we are going to take up just directly the given angle and we are going to rotate either a prism or a pyramid. Okay, both will remain same when it comes to the third position. That is what is important. So just to have again one summary sheet where we said, right, in HP we'll be having two options, either edge or a corner, and with respect to the HP, in prism we'll be having only the axis, but in a pyramid we'll be having the three options: axis, slanted, and a slant triangular face. So we have just located here slant edge resting on corner, slant triangular face resting on a edge. Okay, and the third position again we'll be having the three options where one resting edge will be inclined, and there will be two options for locus and non-locus line problem where we need to look for either axis is inclined or axis is appears to be inclined. Okay, and there are, if you are going to refer to the BTU primer, there are two exceptions where we say the construction itself. One is a tetrahedron, that's the equilateral triangular base. Okay, we cannot say it's a pyramid because they are not going to mention the axis line. And one more is a solid diagonal, that's a hexahedron. Most of the time students will get confused. Hexahedron is nothing but a cube, and a solid diagonal is nothing but a line which joins from one bottom corner to the one top corner. Okay, those are the two exceptions. So for that one we have mentioned that in the summary sheet. Okay, so easy to get 30 marks which is required here. Okay, and yeah, maybe I forgot to add one more slide where actually we wanted to explain the visible and invisible line. Okay, so if it is resting on a side, the resting side will be invisible. Okay, and if it is resting on a corner, it is like a Faraday's left hand rule. There will be three lines which are originating from a corner. All those three lines will be invisible. And the second thing is the boundary lines. Always the boundary lines will be visible. Okay, so next one more very important thing is crossing lines. We say if one line is visible, the lines which are passing through that one are passing across each other will be invisible to us. Okay, if you can remember those three things, easily you can go with the visible and invisible lines. Okay, so that's about 30 marks. That's question number 2. And when it comes to question number 3, that's isometric. Okay, so here very simple thing here to be remembered here is you need to have the angle. Okay, so we'll have 30 degree, 150 degree, minus 150 degree, and minus 30 degree. Okay, so always we are going to have a line 30 degree, 150 degree, minus 150 degree, then 30 degree, like this. Okay, then the height will be taken from each corner like this. Okay, then again if it is a same prism, so we are going to have the same here. Okay, so if it is a pyramid, normally what we do, we'll have the base like this, So from the center we take up the height, then from each corner we are going to join the lines like this. That's about a pyramid. Okay, this is what is very important. And one more important thing is, like, we are going to have a scale factor. Once you do everything right, you need to convert the whole solid combination of the solids into the isoscale, where it comes to a 0.8164. Okay, and one more very important thing is, whenever we are going to get a polygons, these three polygons, either a triangle or pentagon or hexagon, very important is you need to have a 2D sketch. Say for example, if it is hexagon, we need to construct one hexagon like this. Okay, then we need to inscribe this one with either a rectangle or a square like this. Okay, then you need to follow this one in order to construct a isoscale like this. Okay, that is what is very important. Okay, so this is what is very important. And one more important thing is, when it comes to a circles, okay, when it comes to a circles, we are going to use a tangent arc method. Okay, but we need to remember, like, to draw a circular base, either a cone, okay, or maybe the cylinder, okay, cylindrical block, or anything, hemisphere. Okay, so we need to have a square equal to the diameter. Then we need to construct a circle with respect to the tangent. The rest and all will be very simple. Okay, and one more important thing to be remembered here is, there are two important things, like a sphere and a hemisphere. Okay, so to draw a sphere, okay, we need to complete the first solid. Okay, then from the center of the top face we need to draw a radius, then we need to convert that one to the isoscale using this scale factor. Okay, then after coming back, or after converting to the scale, then you need to go with the circle equal to the diameter. That's very important. Okay, for even hemisphere, again same, we are going to have, say for example, if there is a square block like this, we are going to have one cube like this. Then next thing is, locate the center of this cube line, and from there, like, have the radius. Say this is the radius. Now convert this one to the scale. Then once you convert to the scale, come back and take this as a center, then draw the circle. Very important. That means you just observe here. Many times you get told, right, this line is not going to touch to that circle. Okay, so that's how exactly we're going to draw the sphere. So if you take a hemisphere, so if I have the top face something like this square, okay, so locate the center, then draw the radius, then drop the top face of the hemisphere, again a circle here, something like this, then convert this one to the scale. Now come back and draw the arc like this. That is the hemisphere. Those two are very important. Okay, and one more important is this one. For each and every polygon, like a triangle or a pentagon, so you need to draw the 2D sketch, then you need to proceed with respect to the isoscale. Okay, that's a very simple to get a 25 marks. There's a one more option where people where the examiners will ask you to convert the iso into the orthographic. They will give a 3D picture, and you need to look from the three ends, that is the front, top and side view, and then you need to draw the 2D sketch. Okay, so that's it for the isometric, which carries a 25 marks. And most of the time people will forget in order to convert that one to the scale. So keep in mind to convert that one to the scale. Okay, and the last one is the development of a lateral surface of the solids. So this is little tricky problem, where you need to read the problem and extract the data. Okay, so in that one, to identify like how exactly we need to go with the problem, so we have some 4 categories, and normally we say like 3 steps in order to identify the problem, we say. Okay, so one is a type of a problem. What type of it is? Either it's a prism or a pyramid or a cone or a cylinder or a funnel. Okay, so if it is a cone, you need to remember the formula R divided by L into 360, and that is a sweep angle. Or if it is a cylinder, we need to remember like the width of that one will be equal to 2 pi r. And if it is a funnel, again combination of these two only. Okay, so these are very three important and tricky problems where we need to understand. Okay, that's the first type of a solid. Next will be position of a solid. How exactly it is positioned, whether it is resting on an edge or a corner, or maybe the edge is inclined. Because in the planes of the solids, normally we get it is resting on side or corner directly, but here to say it is resting on edge, they will say edge is parallel or edge is perpendicular. They won't say directly it is resting on the edge, or the edge is inclined at some angle. Okay, and in order to identify the resting on a corner, they will say edges are equally inclined. So most of the time they will use this one for either cube or maybe the square prism. Okay, they will say like edges are equally inclined, or the rectangular faces are equally inclined. That means it is resting on the corner. Okay, so that is what is important. Type of solid and position of a solid. Next one is inclination of the cutting plane. Okay, where the cutting plane is inclined. So there will be two options in that one. Either it should be inclined to the HP, or it is inclined to the axis. Even though if it is inclined to the axis, we will take up that one as a 90 minus of a given angle. Okay, so that's how exactly we are going to take it up. So next will be position of a cutting plane. So we know like where exactly the cutting plane is inclined, but where exactly it passes in the solid is identified either with respect to the bisect to the axis, midpoint of the axis, left corner, midpoint of the top face, etc. There are plenty of words where they can use, but commonly used are these things. Okay, they will say the cutting plane bisects the axis. Okay, or it passes to the mid of the axis, or it passes from the left corner of the rectangular prism, or it passes to the midpoint of the top face, either side of the top face, or maybe 30 millimeter from the vertex or apex, or 30 millimeter from the base, like that. Okay, we need to identify like how exactly it goes. So just to know like how we can identify the things. So I have taken one example here. Okay, so where how to identify. So type of a problem, we can say there is a square prism. So the type of solid is now it's a square prism. Now position of the solid, you just continue, is resting on HP with all vertical faces equally inclined. Okay, so equally inclined means all are inclined at 45 degrees. That is nothing but resting on the corner. That's the second one. Okay, now inclination of the cutting plane, you just continue that. It is cut by a inclined plane 60 degree to the HP. I said like there are two options, either it is inclined to the HP or axis. If it is inclined to the HP, you can take it directly 60 degree, or if it is inclined to the axis, you can take 90 minus of axis inclination to find out that. So that is what is inclination of the cutting plane. It is 60 degree. Now where the position, right? Now you can see, and it is passing through a point on the axis at a distance 15 millimeter from the top face. So this is the top face. Okay, 15 millimeter down on the axis. This one 15 millimeter down. So from this point you take a line which is inclined at 60 degree and continue it, or go to the extend to next and extend it. So you will get a cutting plane. So you take up any problem with respect to the development, and in the development you need to look for these 4 points only. Okay, you just take up any problem, type of a solid, position of a solid, inclination of the cutting plane, and position of the cutting plane. So once it is done, okay, then the rest will be easy for us, because here is a square prism. When you cut and open up a square prism, so we'll get a 4 rectangular faces. So if it is a pentagonal prism, 5 rectangular faces. Okay, so as I said, like if it is a cone, okay, the sweep angle will be equal to r divided by l into 360. Or a cylinder, it looks like a rectangle, the width of that will be 2 pi r. Okay, like that you need to just identify each and every problem and go with the solution of that one. Okay, the very first thing, okay, to get a good marks or to understand the things, first you need to have a clarity on the concept, first thing. Next thing is take your own time to read the problem and write it down, the data what they have given. Okay, as we said, like in the planes HP, HP, VP, or in the solids HP, HP, VP, you write down, okay, first HP, there are only 2 options. Okay, so which one they have given, identify in that way. Okay, or with respect to the HP, if it is a prism, we have only one option, axis is inclined. Okay, or with respect to the pyramid, we have 3 options. One is axis, then 2 will be slant edge and the slant triangular face. Okay, and the third VP, either resting edge or axis is inclined. Axis is inclined, locus line, axis appears to be inclined, non-locus line problem, like that. So then the things will be easy for us to move with respect to the solution. Okay, so that's how exactly we move on. Okay, so this is what I felt like. These are the things which are important. Okay, and we might have taken like more examples, but the video will go a little more lengthy. Okay, I don't want to do in that way. Okay, it should be precise. So if you have any doubt, okay, just comment here, or you can ask at any time. Okay, so thank you.